Hi. Well, this is going to be the last section before we take a test, our first test. And this is section 8.3. And what we'll be doing is we're going to be graphing inequalities on a coordinate system with the quadrants. So we'll go ahead and we'll get started. Now, here are solutions to our inequalities. We now have two variables here. So we have inequalities in two variables. We'll just go ahead and read through this. In section 8.1 and 8.2, we graphed inequalities in one variable on a number line. Now we will learn how to graph inequalities in two variables on the XY plane, on the coordinate plane. Now that we have two variables, the solutions to our inequalities are ordered pairs. So we have different solutions and we'll be writing them as an ordered pair. You have to be careful. When we're writing these as ordered pairs, you don't think of interval notation, because they use the same symbolism. But this represents an X coordinate and a Y coordinate. And you're going to know that just because of the way the question's worded or how they want the answer. Okay, so let's go through these. Check whether -3, 2 and 6, -7 are solutions of the linear inequality 5x minus 4y greater than or equal to 13. Oh, by the way, at the end of this, I'm going to go to Pearson and show you how to graph using Pearson and how to shade using Pearson. All right. And how to get the lines, how to get the dash lines, things like that. All righty. Well, let's just a second. I need another pencil. All right. So in order to solve this one right here, I'm going to put -3 in for the X. I'm going to put 2 in for the Y. These are done separately. These 2 points are done separately. And then make sure whatever we get over here is a larger number, is greater than 13. So that's kind of a little outline of what we'll be doing. So we have 5. I'll just write the equation. I'll just rewrite it. So starting with this point, we'll put -3 in for X. And 2 in for Y. And we want to know if that's true or not. And if it is, then it's a solution. All righty, so we've got -15 minus 8 -15 subtract 8 is a -23. I was kind of double checking. I'm going back over my work while I'm writing and make sure that, okay, is this true? Is a -23 greater than 13? And the answer is no. This point is not a solution to this inequality. Let's try 6, -7. See what we can get. So we'll take 5 times 6, subtract 4 times a -7. Is that number greater than 13? 30 plus -4 times a -7 is a +28. Is the number 58 greater than 13? Yes. Therefore, that point is a solution in that inequality. So you just put the points in and see. And if it were an equal sign, we do the same thing. Just put it in there and see if it's true or not. All right, well, let's get to graphing. All right, to graph a linear inequality in two variables, first solve the inequality for y. So before we were doing, you could use the x and y intercepts to graph. But because we're going to be shading, because our solution can be found below the line or above the line, we're going to get the y by itself. It makes it easier with the shading. All right. Now, after that, well, let's go ahead and just do that first step. So we need to get the y by itself, and in this case it is. We have y is less than or equal to x. Now we're going to graph the line as if it were an equal sign. So we're going to use the y equals mx plus b idea. Okay. So before we go to the b, okay, what's being added to the x or subtracted, that tells us our y-intercept. Well, since you don't have anything here plus 0, we're going to go to 0. There's our y-intercept. Okay. Then our slope of our line, 1 over 1, up 1 over 1. So this part is the same as if it were an equal sign. Now it's a little bit different. Now you have to pay attention to this. First off, when you connect these points, if you have the equal, it will be a solid line. If you do not have this bar, this equal, it's a dashed line. Because we have this, the line connecting our points is dashed, or excuse me, is solid. So we're going to connect this up with a solid line. And again, it is solid. And I'm kind of going through this slow in case some people haven't seen this before. The reason it's solid is because of this bar underneath. What that means is that the solution can be found on the line itself. Any point on the line will work in this inequality. All right, now, but there are other solutions. So now what we're going to do is shade the area of the coordinate plane determined by the direction of the inequality. So we have a region of solutions, not just on the line as if it were an equal. We now have a region of solutions. Okay, if the inequality is of the form y less than mx plus b, which ours is, in other words, get the y by itself. If it's a less than or equal to, you will shade below the line. So less than, below. If it's a greater than or equal, then you will shade above the line. We'll go through some examples, so hopefully you'll catch on. This right here is a less than. So we want the y values that are less than the line or below. So we shade below, and I'll show you how to do this in Pearson if you don't already know when we get done with this. I'll show you how to shade. So what does this mean? It means that any point in here, any point you pick will work in this inequality, right? Any point above the line will be false. It will not work like we did in the last two. So you could check these and pick a point. Unfortunately, we can't pick. I like to pick 0, 0 because it's really easy. But if we were to pick any point in this region, let's go with, how about, let's go with 2, -2. It should work because it's in our shaded region if you shaded it correctly. 2, -2. I put in, I'm going to copy that because I have my slope in the way. If I put 2 in for x and a -2 in for the y, it should be true. Is a -2 less than 2? Yes, so it works. So chances are you shaded it correctly. All right, good job, as long as you did this part right, as long as you did that part right. Okay, so let's go ahead and practice a few of these. Let's go ahead and practice and see what we can do. All right, let's look at our next page. We'll go through our steps. It's not too bad. Given this example right here, we have 8x, lots of room, which is nice. All right, I'm going to get the y by itself. Now, if that was an equal sign, I would use the x and y intercepts to graph this because both of these go into the 24 evenly. So I would use the x and y intercept method from the chapter 3. So here we're going to get the y by itself with these inequalities. So we're going to go minus 8x, minus 8x. So we've got 3y greater than, I'm going to put in the form y equals mx plus b, I like to put my x's first, because it matches. Okay, so we brought the x over. We had these two-step equations. Divide by 3, divide by 3, divide by 3. I don't have to flip the inequality because I divided by a positive. This is a negative 8/3 x plus 8. I almost said 6, but that would have been right. So now we're ready to graph. Now that the y is by itself, we have our first step. I'm going to go ahead and put my 2 points in, and then I'm going to come back and see, is it a solid line or is it a dashed line? Well, let's go ahead with the 8. 6, 7. Okay, it fits. Good. So there's our y-intercept. Now our slope is a negative 8/3. So I'm going to go down 8. I'm going down instead of up because it's negative. So I'll go down 8 and to the right 3. 4, 5, 6, 7, 8. 1, 2, 3. So there's our other point. Now, to tell you the truth, you're going to have to decide before you start to, well, maybe not. You might have to decide if it's going to be solid or dashed and click on that before you start graphing, but you might be able to change it. We'll look at it. I've always just picked the line dashed or solid on Pearson first. Okay, now when we connect these, do we want to connect these with a solid line or a dashed line? Without the bar, we're going to connect it with a dashed line. So we've got one. Okay. Now Pearson will automatically do that for you, which is nice. What does that mean, dashed? If it's dashed, the solutions to this inequality are not found on the line itself. The solutions are going to be found above or below, depending upon where you shade. But the solutions themselves from this line, cannot be used in this inequality. They're not a solution on the line itself. Well, let's go ahead and see where we're going to shade. We have y's greater. Now, if it's greater, we shade above the line. And above the line is right up here. We have greater, we want y's greater than the line, and those will be above. Okay, let's try another one. Going through our steps. First off, I guess I really don't need this one. We're going to go ahead and get the y by itself. So let's do that. We have 6x minus 2y less than 12. To get the y by itself, we'll subtract 6x first. Okay. I put the 6x in front of the 12, and then we'll divide by a negative 2. Each of our terms. So y, okay, now I'm dividing by a negative. The last one, it was a positive. But because I'm dividing by a negative, the same rules as we learned in the last 2 sections in chapter 8, we flip the inequality. So then we have a positive 3x and then a minus 6, reducing those fractions there. Now we're ready to graph. So we're going to go to a minus 6 on the y-axis. That's the y-intercept. So 1, 2, 3, 4, 5, 6. Okay, there's our point. Then our slope is 3/1. So we're going to go up 3, 1, 2, 3, and over 1. So put your whole numbers over 1. And we now connect it up with a solid or a dashed. Because you don't have the equal, we will connect these with a dashed line. And this just means that the solutions to that inequality will not be found on the line. It's like an open circle, not included. These points on this line are not included in the solution. Okay, now do we shade above or below? Well, we want y's greater than this right here. So if it's a greater than, you go above. Okay. And you can always pick a point like 0, 0. I like it with 0, 0. If you put in 0, 0, you're saying it's going to work because it's in your region where you think all the solutions are. So if you do put in 0, 0, 0 greater than 3 times 0 is 0 greater than a negative 6. Yeah. All right. So it looks like you shaded correctly. All right. Let's do some special cases here. And then we're actually going to come back to this idea of solving with the two variables. But I wanted to talk about these. What happens if you have x is greater than a negative 3? Or y is less than or equal to 4? Well, we know from our last chapter that if you have an x by itself and no y, it's a vertical line. And this vertical line will hit the x-axis at a negative 3. So in Pearson, and we'll talk about this as well, you go here and make a dot, and then you just kind of go up and make a dot. It's a that creates the vertical line. And then you decide, do I want it dashed or solid? Well, in this case, it looks like we don't have the equal underneath or equal bar. So we're going to dash it. Where x is greater than a negative 3? We want x is greater than a negative 3. And that's to the right over here. All of these points have x's greater than a negative 3. Perfect. Let's look at this one this next example. Y is less than or equal to a positive 4. Now, we know that from our previous chapter that this is a horizontal line. It will hit the y-axis at 4. So you go up here, make a dot, and then just make a dot so that you create a horizontal line when you're using Pearson. Solid or dashed? Well, you've got the equal underneath, so it's solid. That means that the solutions can be found on the line itself. And where do you shade? We want y's that are less than 4. Okay, this represents your 4. We want y's less than or below. So we'll go below. All of these would be your solutions. All righty, good. All right, let's go ahead and put these ideas together as we get ready for what's called linear programming. Let me move this up a little bit. All righty. We can also graph systems of linear equations. To do this, just graph and shade each inequality like above. The solution to the system is the area where all the shading overlaps. We're going to go ahead and graph these lines separately. Getting the y by itself, we'll start with the top one. We have x plus y less than or equal to 4. So we'll subtract x. Y is less than or equal to a negative x plus 4. Okay. So we'll go ahead and graph this one. Let's go ahead and graph it. We're going to go to the 4 on the y-axis. 4. And then we're going to go down 1. This is a negative 1 over 1. So down 1 over 1. Solid line because of this right here. Go ahead and put the solid line there. I'll probably do the other one in a different color. So we have a solid line. Where will this be shaded at? This will be shaded below the line. I'm going to kind of do it light. for right now. So we're looking below the line. All right, let's go to the next one, our next line, and solve it for y. X minus y less than 4. Subtract x. A minus y is less than a negative x plus 4. Divide by a negative 1. Get rid of that negative in front of the y. Great, because you're dividing by a negative, you flip that. All right, common mistake is to forget. It's easy to do, but try not to. Negative over negative is a positive x minus 4, reducing those fractions. So on this one right here, maybe I'll try green. Maybe it'll show up differently. We'll go to a minus 4 on the y-axis. 4. Will that look any different? Yeah, kind of, not much, but kind of. Our slope is 1 over 1. Up 1 over 1. I will connect these with a dashed line. Now, when you're doing Pearson with these, you have to wait to shade till the very end after you graph both lines. Part of this you kind of have to do in your mind. Now, we want the region above the line. So we want the y's above the line, and that's going to be over here. Now, what region is shaded for both of them? Below this one and above this one. And that's this region right in here. Any ordered pair in this region will work in both of those inequalities. They will work both, such as 0, 0. 0 plus 0 is 0, which is less than 4. And 0 minus 0 in this one is 0, which is less than 4. Okay, so you're going to shade the common region. You darken that common region for both of them. This first line was below, and the dashed line was above, and the region that was in common was this region right here, over there on the left. Awesome. Okay. 2 more to go and we're done. What about something like this? How do you graph these right here? These are actually lines. Well, here you have 2 vertical lines because it's an X. If it were a Y, I'd have 2 horizontal lines. I have a vertical line at a -2, and I have a vertical line at 3, and I want the region in between. Is how you would solve that. So we're going to go to a -2, and then we'll just make a dot above that. Now we're graphing. Let me see if I can cover this up a little bit. What we're doing is we're just graphing this part right here. X is greater than a -2. We know it's vertical. We're missing the Y. We know it's a vertical through a -2. And we also know it's going to be a dashed line. So dash the line. Here. Now, so the solution is not found on the line. This one right here, we want x's bigger because, we usually have the x on the left. But here we want x's that are bigger than a -2. So we know it'll be over here in this region. Graphing the other one, x is less than or equal to 3. We're going to go to 3. And then we go above. Create a vertical line. This one's going to be a solid line because of the bar underneath. So we'll make it a solid line. And it looks like we want x's between those two. Less than the 3 and greater than the -2. So you would shade right in this region right here. Awesome. Okay, now let's go to our last one. Our last one will take a little bit of time. This is getting you ready for what's called linear programming. But what we're going to do is we're going to graph the system of inequalities. And then we're going to find the coordinates of any vertices formed. So we're going to find out where they intersect. And I've tried to keep this pretty simple in your homework. They may just have one of these. But we're going to solve this first one for y and graph it. And we'll look at this next one and graph it. And then this one and graph it. And there's going to be a region that's bound between these, and we're going to shade in that region. Let's go ahead and go through it. 6x minus 2y less than or equal to 12. Subtract 6x. Negative 2y is less than or equal to a negative 6x plus 12. Divide by a negative 2. So y then is greater than or equal to, flip the inequality, 3x minus 6. So if I were to graph this first one, I would go to a minus 6 on the y-axis. 4, 5, 6. Okay. Slope is 3 over 1, up 3 over 1. It's a solid line because of that bar there. So we'll make it solid. And keep in mind, I don't know if I guess we could do this. We could shade real lightly because we're going to be looking for a common area. So it's a greater than, y's greater than or above. They're above. Greater than is always above. I'm going to make it real light just so I know. Our answer's over there somewhere. Let's go to this one right here. Y minus 3 is less than or equal to 0. You add 3. So then we have y is less than or equal to 3. When you don't have an x, just the y, it's a horizontal line. It's going to hit the y-axis at 3. 1, 2, 3. And then we'll just move over 3, and I'll probably do this one in red. Dashed or solid? Oh, let me look. Well, looks like all of these are solid. All 3 of those are solid. So we'll just graph it. It's a solid line. This one, we want y's less than, so it's below. Well, if it's below this one, and we want to include this one, it looks like we're in this region right here right now. It's somewhere in here is where we have, because we want it above the pencil and below this red pen. So it's that region. We have one more to go. X plus y greater than, x plus y greater than or equal to 0. Make sure you copy those right. It does matter. Subtract x. So we have y's greater than or equal to negative x. Negative x and 0 is just a negative x. So these are the 3 lines that I have graphed. Okay. Now what we'll do is we'll go to 0 on the y. I guess we'll just do the green. It hits at 0. We're going to go down 1 and over 1. And like I said, all of these are solid because they all have that equal. Whoa. So I'm going to connect these up here. And I want above the line, which means you're above the green line. So we know we're over here and we're above the green line. It looks like this is our region where solutions would be found that would work in all 3 equations. So we went above the pencil, which was up here. We went below the red and above that, and it enclosed that region. So that is the graph of the system of inequalities. But what's this next part? This next part is what makes linear programming kind of tough. Linear programming has applications in business and other applications that you'll talk about, especially in your 1400. All right. What we're going to do in order, they want to know these points. These are called the vertices. So I want to know these points right here where that region is enclosed. So to find that, we take the equations, I'm just going to use these right here, and we make them an equal, because we actually want points on the line, not above or below. And we have y equals 3, y equals x. And we can solve these equations. Like, let's say I wanted to, okay, this one is the pencil. Let's see, this one was the pencil. This one was the red. And this one was the green. Okay, let's say I wanted to know, where does the pencil and the red intersect? Well, y is 3. So you make y 3 and you can solve it for x. Okay, so you put that in here, into that coordinate. Right, I can't think of an easier way. 3 equals 3x minus 6. So the y became a 3. And now you solve it. You add 6. So you have 9. Divide by 3. X is 3. So this is the point 3, 3. And it looks like it on the graph too. 3, 3. That's one point of intersection. Now we want the pencil and the green. Well, for the pencil and the green, the y and x mean the same thing. So if y is x here, I'm going to use these two equations. If y is equal to x, I'm going to substitute it in right there. And solve it for my x. So I'm going to subtract 3x. Let me get another piece of paper. I'm running out of room. Minus 2x equals negative 6. Divide by a negative 2. Let me move this up. Divide by a negative 2. X, put those together. X then is equal to 3. Well, if x is 3, then y is 3, because they're equal to each other. The x and y's are equal. So here is the point. Oh, what did I do? Okay, negative 3, negative 3, negative 2. So the x is 3. And the y is 3. Did I use the wrong lines? Did I do? No. All right. Let me back up here, because that's not the point. That looks like the point. Yeah, it looks like about the point 2, 2. The pencil and the green, where do they intersect? X minus 3x minus 2x minus 6. Oh, so frustrating. Minus 2, x is a positive 3. But that's the red. What is going on for these points of intersection? And the red and green. If y is 3, oh, I copied it down wrong. That's why. That's a negative x. That's a negative x. So this is a negative x. I knew, all right, it just had to take me a second and get rid of this. This is crazy. I hate it when I copy those wrong. Okay, so that's a negative x. Sorry about that. So the y is a negative x. So we have a negative 3x. And that's going to give us negative 4x equals a negative 6. Much better. X then is negative 6 over a negative 4 when you divide by a negative 4. So our x coordinate of this point with the pencil and the green is a positive 3/2. So if x is a positive 3/2, y is the opposite of that. So we have a point, this is the point 3/2, negative 3/2. Much better. Just did not catch the fact that I copied that down wrong. And now we're going to go over here and find the intersection of the red and the green. The red and the green are these two, which says y equals 3 and y equals the opposite of x. So here, if y is 3, you could put the 3 in here, divide by a negative 1, x is a negative 3. So if x, so you have the point negative 3, positive 3. Okay. So that's how you find those vertices. I'm trying to think if there was an easier way to do those. Yeah. Here on these red lines, you know that the y is 3 on the red. Well, yeah, that'll work. It's okay. I don't want to confuse you any more than maybe I already have. So again, that's how you find the vertices and that's how you find the intersection. What we're now going to do is we're going to look at how to graph these. So I'm going to stop share. And then I'm going to go to share screen. Hopefully it hasn't kicked me out of this. All right. So what we're looking at, your session is ended. Sorry about that. Okay. So I'm going to have to go back in. I was gone too long. So I wasn't, oh, let's see. Oh, it's working. All right. Awesome. I'm going to put it right here. All right. So some of the ones that I wanted to look at were number 4. This is on your homework assignment. Good. It's going to let us do this. All right. What I like to do, you can click to enlarge the graph. I'm going to move it over so I can see the line we're graphing. The y is by itself. Okay, now this one right here, you see you've got, you know you're going to be doing a line, all right? And you also know that it's going to be dashed. So here are your choices. If you want it a solid line, you'll click this. Or if you want a dashed line, you'll click this. And we want a dashed line because my points are moving all over the place. Because there's no bar underneath. Our y is greater than x minus 6. So we're going to go to a negative 6 on the y-axis. And then we're going to go up 1 and over 1 and click. So you've got your dashed line. Now, how do you shade? Well, we want the y's above. It's a greater than here. So we're going to go above. So you go to this paint can and you click it. And then you come over here and click in the region you want. And it shades it. So it's this paint can that'll shade your region for you. Then you can save it. And then you can check your answer. Looks pretty good. All right. Next question. Yes. Here you can click. Sometimes there's another button. Maybe it'll show up on one of these. And you are going to be, I'm going to move it over so we can see our equation right here. I wonder, I'm not really sure how this is showing up on yours. I'm hoping you're seeing the pop-up. I really am. But if not, I can just talk you through it. Sometimes I don't know. I wonder if I have to share my screen. I'll try this and then I'll share my screen because that may be what you may not be seeing this little pop-up here. I am going to go back. I'm going to stop share. I'm going to share my screen because I don't want to go too far and then find out, oh, they couldn't see anything. Let's see. Screen, just in case. Okay, I'm sharing my screen. So we're on the second one. If it didn't show up on that first one, you'll get this one. Okay, so we have this pop-up. All right, I just clicked to enlarge the graph. Now we're going to go to a +5 on the y-axis. I'm over here looking at my equation. Yours will be different. I'm going to go to, I'm going to have a line. And instead of being dashed like the last one, I'm going to do solid because of the bar underneath, the equal. I'm going to go to 5. Oops, go up to 5. And yep, I'm there. And then the slope is 1 again. 1/1. Perfect. Yep, and it made a solid line. In order to dash, you go over to the paint, or excuse me, in order to shade, you go over to the paint can. And we want y's less than. So we're going to go below. So you take your paint can, you go below the line and click anywhere. It doesn't matter. And it'll shade it for you. Save. And there you got it. All righty. So that's kind of how you do the dashed. There was one other one I thought we could look at. You will not receive any credit. Okay. That's okay. Are you sure you wanted to continue without checking your answer? Yes. I do. All right, how do you graph something like this? X is less than or equal to 2. Well, you'll go to, and when you have more than one and you want that one region, when you're done, you go to the paint and you look to see where they have a common region, and that's where you click. You guys should be able to figure it out. I'm going to go to X equals 2. It's a vertical line through 2. So let's see, we go 1, 2. Oops. Got to get the, yep. So here we're going to go, it's a line. And let's look, it's solid. So rather than the dashed, we'll do the solid. Click on that and click on this. And let's see, we're going to go to 2. Click, and we'll just go up. Make it a vertical line through 2. We want x's less than 2. All the x's that are less than 2 are on the left. So we'll click our paint can. We'll come over here and click in that region, and we've got it. And we can save. All right. Well, I hope that helped. The only one I'm concerned about is that last one and finding those vertices, because we haven't really looked at how to do simultaneous equations, but you might have been able to follow. The most important thing is to be able to graph these inequalities, maybe not so much find the vertices. Okay, let me know if you have any questions. Thank you.